Hi everyone, in this video I'm going to focus on inverse function. If we have a function of f of x, f of the negative 1 of x, we can show this one as a inverse function of f of x. For example, when we have a graph, if f of x and g of x, two different functions, two different one-to-one function. This is one-to-one. It means that for any x there is just one y. You see that? If they reflect across this line, y equals to x, y equal to x is all x and y are equals, okay? If they are symmetric over this line, we can say that f of x and g of x are inverse to each other. Okay, and we can write g of x as f of inverse of x. Okay, this is graphically, in general, it means this one. But why we need to have one-to-one function? Because if you have one-to-one function and reflect across this line, you have a function too, because you know the function means that a relationship between x and y, that for any x we need just a single y. Okay, if we have, for example, this function, this is function, this, for example, this function is x squared, y equal to x squared, yes? Okay, if we reflect this one over across this is roughly gonna be this, yes? This one is reflection of y equals to x squared across this line. Yeah, but the problem is this one is not a function, because for one single x we have two y's. That's why we need a one-to-one function to have a inverse function. This is the reason for that one. Okay, now if f of x and g of x are one-to-one functions, and the composition of these two function is, we write as f of g of x, g of f of x. If they are equals and the result is x, we can say these two functions are inverse to each other. Okay, and it means that they undo each other. Okay, what it means? It means that, very simple, I can, if you have f of x like this machine I had before, very high-tech machine like f of x, you know, x is input. Yes, this machine is a function. When we have an input, what is the output? The output is f of x or y. Output, yes? How about g of x? If we have another function, the same. X is input, output is g of x or y, right? This is the machine of g of x. Okay, but if as an input with this one, we use this one, g of x, input is another function, g of x. Okay, input is another function, goes to this machine, is machine inside another machine. What comes out is not f of x, it is f of what? G of x, right? This is composition. composition of functions. Okay, we need to know about the composition of function, a function inside another one, or a machine inside another one. If input is this one, f of another function equals to g of and this f of x inside gets x, we can say that they are inverse to each other. What it means? Algebraic means this. Uh-oh. Okay. It means that if we have this one as x's or input, okay. Input is domain, yes? And this is y or f of x or g of x. If x goes to any element of this domain, goes to this one by this function. This function bring this one x to range, okay? It gets f of x, right? If there is another function that any can brings any element of this one to from range to domain, exactly from this one to this one, we can say that this one, this, if exactly goes back, if exactly from here goes back to here, we can say that this g of x, this function is inverse to this function, and this function is inverse to this function. It means that if you have, for example, 2 by this function, what is this function? 2x. Okay, this is 2. 2 times 2 gets 4. Yes? If you have another function to use, this one comes exactly back to this number from 4 gets 2. This is inverse to this one. Okay, so we can conclude that the composition of 2, if we have f of x or g of x, if they are one-to-one functions, they are inverse to each other, it must be the composition of this one equals to this one equals to x. Because x goes to other side to range and comes back exactly to its place. Okay, now, for example, we have an example of this. Just we want to know, find inverse function of f of x when f of x is, for example, 2x plus 5, right? If f of x is 2x plus 5, what is inverse function? Okay, what can we do? F of x is y, right? 2x plus 5. They are inverse to each other. The x of this one is y of the other one. The x of this one is y of the other one. Okay, for example, if this is f of x, the table of f of x is this. 1, 2, 0, 1, 2, or 3. It gets 2, 4, 6, for example. Okay, the inverse function table is this. For 2 gets 1, 4 gets 2, 6 gets 3. Everything shifted. Yes. Okay, we can use this one. Y equals to 2 x plus 5. What can we do? We can change any y to x, any x to y. Here we have x equal to 2y plus 5. Yes? And now we must solve this one for y. Because this y is here, y of this one. Okay. What can we do? Just cancel negative 5. X minus 5 equals to 2y. We are going to find y. What can we do? Divide by 2, everything. Both sides. Okay, so the answer is y equals to x minus 5 over 2. This one is the inverse function of this function. Okay, here is y equals to x minus 5 over 2. Right? Okay, what can we do if we are going to find something, a function, inverse function of this one? We write the function as a y equals something and shift this one. For any y, we can write x, for any x, y. And we solve this equation for y. And this new equation, y equals something, is the inverse function. Okay, hope you like this example. I come back for checking this one with new examples. But before finishing this video, I need to show something else. I say that y equals to x minus 5 is inverse function of this one. But how can I check this one? How can I show this is right? Okay, I said if f of x and g of x, two function, are inverse to each other, the composition of them must be implies x. Okay, we have two functions. F of x equals to 2x plus 5. F of function, inverse function of x is x minus 5 over 2. Right? I want to check this one if they are, this my answer is right. What can we do? I say that we use this one. This is f of x. Okay. If f of this one, if the answer of this one, composition of these two, gets x, the answer is right. Okay. What can we do? F of x. F of x, 2x plus 5. 2x plus 5. What is x? X is this one. What is this one? X minus 5 over 2. Okay, just simplify. 2 times the parentheses, divide by 2, cancel out. X minus 5 plus 5. Minus 5 plus 5 cancelled, and the answer is x. Good. If we use the other way, for example, f inverse of x inside of this one gets f, the answer must be x. Okay? Just review this one. If two functions are one-to-one functions and are inverse to each other, then you can use this formula, exchange or shift x and y, and find the other one. And if you use the actually not multiplication, but we can composition of these two functions must be x, because one of the function goes from input to output, and the other one, inverse function, must come back exactly to x. Good? Okay. I see you later with another example, maybe a little bit complicated example. I know that the inverse function seems very confusing, but if you know these techniques, you can use everything. You can use this one and to solve any kind of question that comes to your test. Have a good day and good luck. Bye.